Hello everyone. Am I audible to you? Hi. Hello. What we had in the last session? Check just a moment. In the last session we have done the performance matrix, right? And I will actually exercise. Are you working on the Python basics and all? Have to work on the Python programming and data analysis stuffs because that is important. Prediction is the next part. No? If suppose if you're going for the machine learning interview process, definitely they will ask the question on the pandas and numpy and basic Python interview questions in tuples, sets, and dictionaries and all list. So you should go for that. Put your time on it. List. Actually, maximum time you have to put a time on list. In the last session, we have covered the performance matrix of content, and side by side, we have to work on now the projects and algorithms as well. And what's the question? ML.NET could. Yeah, actually, that comes under the Visual Studio. I think Visual Studio only you will get this kind of structure, ML.NET and steps, right? Is it correct? Visual Studio 2000, maybe 22, 22 extensions are coming, but you have to use, I think, C# programming language. Is it correct, sir? Because as per my knowledge, ML.NET concept. ML.NET means I have seen one extension, ML extension in machine learning extension in Visual Studio 2022, but C# programming language is there. What more could you ask for besides the library? Actually, see, libraries means the analytical process. If suppose out of this, if you want to learn, you should go for some basic structure about servers, right? Means hosting and all. Is it correct? Hosting as well as basic NLP means what? Chatbot concepts. Basic. Definitely, they will ask the questions. If suppose if you are getting question on artificial neural network, then you will get a question on chatbots, NLP, artificial neural network. These kind of means you have to learn some basics related with that. Some contain what is a TensorFlow, what is a Keras, these kind of structures. right? Is the libraries available in Python is available in .NET? Python libraries. Actually, if suppose if you are using Python in .NET, then Python becomes cross. What is that? Cross-platform language, right? The way we use to develop mobile application, similar kind of that. But libraries, I don't know, sir. Definitely, I will check for that. But means all the libraries that present in Python, no, nowadays that present on .NET means that is compatible with the .NET. I don't know, because .NET is a complete framework to implement web application, right, and Windows application. Where are we now in the course? Are we finished ML or about to finish? I think, yeah, I will tell you now. Yes, yes. We are going to cover the ML libraries, machine learning algorithms. So only remaining decision tree and naive ensemble technique, right? And then we are going to work on another one, that is what's the part is remaining here? Clustering. Clustering algorithm. So this is going to take 1 or 2 more weeks only, because tomorrow I'm going to explain the decision tree, and you will get new batch as well. Ensemble technique will get day after tomorrow. Clustering will is going to take in next week, and after that we'll go for the ANN as well. Clustering and algo ANN. So we'll implement that ANN here. So this week we'll cover up this one, and clustering algorithm and ANN will cover up in the next week. Definitely. So in between that, we'll do one assignment on ANN, because clustering concept will you will not get deeper into that, means questions and all for the interview sessions and real time as well. But definitely you will get an ANN. ANN is a part of ML. I will check that because I have seen one curriculum. ML part is over where when we have covered when we are going to cover clustering algorithm. ML is an based algorithm, and ANN is an artificial neural, means neural deep learning, right? Yeah, it means deep learning. CNN as well. What about Tableau? Tableau Power BI. Tableau will go for I think once we cover up this. It's 2 weeks. After 2 weeks, we will need an extra classes. No, actually, once we cover, no, we'll go for the Tableau as well. I think this month only, almost we will cover up all this. AI part. This is no ANN and CNN. That is an AI part. Artificial neural network. That is only deep learning. Tableau. How much time? 2 sessions enough. 1 week, 4 hours, you know. Convolutional neural network, CN, convolutional. So let me know the way Sunday you all present or not in the last Sunday. I'm just saying about this. Then you have to learn about this Sunday's part. Implementation of performance matrix means accuracy score and confusion matrix. Yes, yes. Actually, I'll change the content here. Check out. Everyone, please. We are implementing last Sunday's content as well as confusion matrix and accuracy score comparison between that, and also advantages we can discuss about pandas as a theory, import numpy as a take one data set. I'll take a diabetes data set, so it will be useful. The topic. Yeah, I'm just explaining confusion matrix. So implementation from the confusion matrix. Have you uh, present on that previous class? That is, we are going to implement, but with the data. Now I think I'll take different data set, diabetes or yes, we have diabetes data set. So can you tell me, there we have so many working concepts now, doing balancing and all, right? So we have to check for once balanced or not outcome dot value count. So this is now used to you guys, right? With this one, yes or no? Means, do you know the concept about imbalancing, how to tackle with that. That is most important. Many people they get confused about what is the imbalancing and what is cross validation. So nowadays, I think the way we are working, no, uh, this is interesting point to do. So we'll go for this content, data set outcome dot value count. So this is imbalancing completely. So you guys, you have to tell me now which library that we have to use for the imbalancing purpose. And before the imbalancing, we go. I'll implement the x is equals to what? X is equals to data set dot ilog, and you should have to pass here the column that you want to go, right? Dot. Okay, you should have to first mention that there is an independent and dependent variable, then you should go for that, right? So maximum time they will ask in the interview sessions that what type of independent variables and means what is the meaning of independent and dependent variables. You have to tell them. Independent means prediction values, means actual prediction values, and independent means your input variables, observations values. So on the basis of observations, we are going to find out the predictions. So and whatever the content say, if you are not getting to tell means what to do, how to give the answers of these kind of questions, you have to write down the question and write down the answers to in your notebook so that you can get how to implement that wordings properly, right? Then there we have imbalancing means working on imbalance. Right. Can you tell me what is the library for the imbalancing from sklearn? What do you think? IMB like this one, IMB learn dot. So what I have to use? Smooth. For the smooth purpose, what I have to use here? If suppose if I want to use a smooth, is that IMB learn dot smooth? What do you think, guys? I'm just waiting for your answers because these are the things that we have already done. Right. Is that correct? Sampling, import, smooth. Right. So most of this is better to pass the libraries here. You can take these libraries and put it down into starting of the means while doing starting the program. Okay, so you can pass here so from imbalancing, oversampling, imports mode. So tell me that other content as well. What kind of libraries we have to put here? Any other libraries that you? you can recommend me? Which one? sklearn dot model selection, is it correct? So what kind of libraries that you have to put here? Import, train, test, split. So another one, sklearn dot linear underscore model import. What I have to pass here? Linear model logistic. From sklearn. What? What is the library for cross-val score? What is the library? Cross-validation score purpose. Tell me. From collections, import counter. Model selection. Yes, import cross-val score. Is that correct? Cross-val score, right? And counter is there. Another one, is there anything that you just left about adding here? From sklearn dot matrix. Is that correct? Matrix import. Yes, accuracy score comma. You can pass confusion matrix too here. See, this kind of library is that important. No, so every time, whenever if you want to work on the means, no. If suppose if you want to work on only and only using oversampling, you can pass only oversampling. Go for the training testing, you can pass only. So better to go for the individually assigned. You can go with this. So what kind of problem here? Confusion matrix. I think spell is wrong. Confusion matrix. Right? K fold is remaining and confusion matrix is one. Matrix is correct. This is comes by confusion matrix. Confusion matrix. It's correct. Yeah. MA is getting wrong. So another one remaining here from sklearn dot. What is the k-fold purpose? What we have to pass here? K-fold means cross-validation technique purpose. Model selection and import. What I have to pass for the stratify, if suppose if you use stratify or K-fold, is that we have to pass any library for that purpose? So I'll use a stratify. So we can check out this one. Stratify and another one. For the K-fold purpose, I think this is easily we can get it, no? Anything is remaining here now? I think all the content that we have installed. And suppose if you want to use here visualization techniques, then you can pass in macro. Okay. So side by side, just we can go for the working in balancing technique. So in balancing already we have used here, right? This is cross-val predict. Okay, cross-val predict purpose. Here we are, no? Okay. Score predict. Anything remaining here? Not maybe two or yeah. This is enough. Cross-val score predict confusion matrix accuracy score counters are completed. So almost three and three and almost 15 libraries are there. 12 to 15. That's good. Right. Let's go for using this one. So we can use this content. So while doing this one, no, this for random oversampling, I'm not doing random oversampling. We are going to work on the smart technique. So I'm just passing this one. Let's do with this. No problem. So I'll use here SB and okay, smart directly use is this is enough. And then I'll pass here X data, comma, Y data is equals to SB dot. We can pass here resample. If suppose if you create a multiple objects, that is also good. But the problem is you have to pass a different values because mode is in class no. So you have created an object of this one as ESP. So if you are passing here another one x2 or x3 and creating some other random values, then you can create here. But getting so much complication, we can do this much only. Okay. So check out print. See what for 500 now because 500 is 0 and 500 now the value becomes balanced. Okay. So 1 and 0 we get a balance. And you know what? I would like to check some. The most of the people they think about the balancing is nothing but the only zeros and ones, right? So here the similar kind of structure that happens into the X data as well. So observation values are also getting balanced. Is that correct? Yes or no? Wait, I will show you side by side this one also. Yeah, X data also count is getting. So I'm not saying counter, but you can get it that balanced shape. See 1000. Now what the point? Because total count is near about 768, no? So that becomes 1000 because of this. This is its value getting balanced that time. So X data is correct now, and counter is also getting balanced. So let's go for the next one. Working with imbalancing and cross validation. Cross validation. This is interesting fact about machine learning stuff. So those people know about the cross validation. Also, it's kind of hard. It's kind of machine learning hard. So how the data is going means every stages, every fold and fold, how the data will go. So if you know this one, no, definitely you will enjoy the next topic also. Curiosity is important here. So working with the cross validation. So now we got in data into the X data and Y data. So how can we pass into cross validation technique? So that is the most important. So can you tell me the what's the next process put into chat and what can I do to implement cross validation technique? Just a second. Right. So let's go and implement this one so we can deploy this. So scaffold, we have to assign that as well. So what we have passed here, which library? Scaffold and smooth. So let's go for this. I'll implement this looping for the scaffold. And today, we can go for some little bit deeper so you can get it. What is the exactly difference, right? So what is the by default count of n split? Is that correct? So kf is equals to a k fold n split 5 and shuffle is equals to 2 and random state is equals to 3. So this is shuffle. You have said that in true shuffling random state you are getting a value into that to the k fold as a randomly with the three difference, and n split is in how many folds you want to create. Okay, so for this purpose k is equals to k fold, we have to implement one thing here, that is here, check out one thing that we have to implement, that is by default value means if you haven't passed, suppose uh, one thing, if you haven't passed split size, then definitely he is taking as a 5 only. So except suppose you are not passing, no, the maximum people they say that I don't want to do a 5 means n split is equal to 5. So they try to make with the folds 2 or 3, or someone is saying that 3 is enough, 7 is enough. Suppose if you are not passing, he is taking n split is equal to 5. So it depends upon you that how much splitting you can do. So you know what? I'm going to take one content here with the because here I haven't implemented that cross validation technique. So we'll do with this one. In the last week we have implemented that. So we'll check for the count. So kf is an k-fold dot get and splits is nothing but x. That is we are passing the values, this. So how many splits we can do in on the basis of this? So we have passed kf, and not an issue because how much implementation that we have here for random straight. This is 5 times. So once I covered this, we have to pass into for loop, right? So for loop purpose, we have to do one thing. So for x train, see what I'm passing, x train, so that I can pass here one x train, or I will take different names here. X index and train index and test index, because we are creating also here index. So in so in purpose we have to pass here kf dot, what I have to pass, split into the bracket. You should have to pass x colon is compulsory. So now tell me, what is the next process that we have to implement? Because if suppose if I print only this much, now we are going deeper. Now check out what I'm going to tell you. Training data. Okay, this is a train index. So we have to check the data that going to the testing and training purpose. This is in 5 times, no? So you are getting this loop in 5 times. See this one. So how many training testing? Training testing is how much? How many times? 5 times. Okay. So we got it easily, not an issue. So it's this loop is executed 5 times. So that's why this is he's showing 5 times. Okay. So I'm not implementing this one. So for the understanding purpose, I'm just passing this one. So I'll just make here one area to pass this kind of structure. Now, what what we have to do here, that is creating this kind of structure. So I'll tell you what it is. Wait. Sorry. This one. See, this part is creation for creating for the making X-train and Y-train. You know that this data, this loop is executing 5 times, definitely. And we are passing X data for the training and testing purpose. So X and simultaneously we are passing Y data as well. So where we have created this X data and Y data here, check out. Means instead of passing directly X and Y into this one, why not you create balanced data and then pass it into the K fold, means into the cross validation. Is it correct? Yes or no? So the X for the observation means for the independent variable purpose, we have created X train and X test, and dependent variable purpose we have created Y train and Y test. As comparatively, the previous time we have used into this one train test split. There also we have created the 4 variables: X train X test, Y train Y test is equals to train test split bracket test size and all, means this kind of structure we have used. Similar kind of work we have covered here. But the point is that every time, see what I'm saying, every time you are getting different data. So you guys are thinking about how it is possible. You guys are thinking about how it is possible. So score is equals to crosswal score. That is easy. See, extreme and express scoring purpose. Score is nothing but without a training we cannot do calculate the score. Is it correct? That's correct. No, means if suppose if you want score something, if you want, that is an accuracy score actually. And without scoring, how can you get? So that we can pass the extraction y score and extraction y test into the y grid as well. So testing purpose and different. And so check out one thing here. What happened? Train data is not different. Where it is in train data. Oh, sorry. Wait, I'll do this one. Okay, sorry. Before you going for this one, you have to create object for the logistic regression. Is that correct? Because you haven't implemented L1 for this L1. So L1 comma X train comma Y train CV is equals to K fold. Cross validation is equals to K fold. Score will go implementation. Y period also gives the implementation of your prediction values. And also, now, see, if suppose there is a notebook to you have guys, please go for some execution of code. What happened to this one? Yes, executed 5 times. I haven't printed no, so that's why we are getting problem. Oh, sorry. Now check out even see one instructional point here. You know, the model score is in almost in between the 70 to 80, right? This is you can calculate the average. You will get a near about 78 or 79 something. Hmm? And for the accuracy average, we can do that. Model prediction. See the model prediction that purpose that here we have one. You just remember these points, last 3 points, and write it down into the notebook if you have a notebook there. Okay, so I'll just copy this one first. See, second, third, fourth, and fifth. Okay, so there we have the calculated the 5 times. So end loop is there, so means not a single point remaining now. See, first one, second. So now you're getting the difference between that into the output. So majority of voting is important. So I'll tell you that how to check that one also. So 000 means already this is true. This is true, no. And majority is in also 0. 1 1 and 3 zeros and 2 ones. So that is nothing but three zeros will win. 3 zeros will win. This is 3 means 5 zeros will win. Means majority of voting always goes into that. So 3 observations we have checked and 3 observations given the proper answer. But here majority of voted categories are wins. But the thing is the difference here. Let's go and discuss about this. Wait, I will copy this comment. Hmm? And instead of assigning this one, no, I'll comment this and print it down. X text. Is that correct? Majority of is 0. Yeah, majority of that is in zeros. See, the way we are getting the data here. So X data we are having here, X data. So every time, actually this is an combined, no? It looks like plus zeros are extra, one zero is extra. So this is kind of data we are getting in loop. So five times. So you have to do a one R&D section here. If you guys getting some time for so you have to do one R&D. Is that data is correct? Means that remaining extra 260 or something adding, no? So where 260 232 data observations already added, extra added with the five times data. No, actually we cannot do the five times data means the work. That five times data is trained to calculate accuracy score and as well as the prediction. But the point is that here we have used SMOT, and the SMOT technique, what is the work he can do? SMOT is used for balancing but artificially creating a data. But what kind of data he can create artificially? See, if you are working on the binary classification only he can increase the balancing purpose here. If suppose there is an 268 data is here, so balancing purpose he can increase the ones data till 500. But what about discussion on X observation values? So she should have to increase the he should also balance there till the 1000. Why? Because you have increased the ones count. So you have to do R&D on the smooth technique and as well as there is a random oversampling. Uh, Means what kind of difference, what kind of data we get increased means duplication of data or artificially creating a data means what kind of concept, what kind of data we can get it here. So so every time you can take a small amount of data, and passing into the smooth and as well as into that another one random oversampling. So you have to check the comparison between the X observations into smooth and X observations into random oversampling. So duplication of data increased. Suppose here we have the 232 count only to increasing purpose. We needed increasing purpose. The point is if suppose if you get a data kind of credit card fraud detection, there is an imbalancing into the zeros count, sorry, ones count because fraud data is in 492. If you applied the smart technique on that, so you know that he's going to increase your 492 till how much? 2,84,000 because the highest count of one category in credit card fraud detection that is 2,84,000. So I'm just thinking about if suppose if you are having a 2,84,000 and increasing the count of your minority class, then what about X observations? Is that correct? I'm thinking same. And many of you guys ask one question: if you are increasing the garbage value till means random values till the majority plus, how can you believe on your model? See, you are increasing the data that present already into your model. And what is the target point? What is our main goal to goal on the machine learning? We have to train our model. So it depends upon you, no? It depends upon you. It depends upon even model as well. Model is learning, not learning. If suppose, wait, I will give you one example. 1,000 data, 500, 500 data. So in that, here we have the 1,000 X observations, X data. And Y is equals to 1, that is 500. And Y is equals to zeros, that is 500, right? And suppose if you are having the zeros are 50, so you know that the 50 observation values also we have, because this, if suppose if you are thinking about this is a fraud and this is an true transactions. So what is the difference that we have? If you are having a fraud data of if you are having a true data 500, then definitely you will get in 500 observation values that become, that is already true. If you have a 50, the 50 also we have, but the point is that you have to increase this 50 till how much? 500. Means your total data, actually you have in 650. Here also we have 650, and applying on imbalancing here, sorry, it's not in 650, 550, and this is your 500 and 500, your data is in this much. And if you apply imbalancing concept, this is become how much? 500. And he is not taking X observations data that is connected with the ones, that is connected with the truths. He's taking and he's increasing only frauds data, fraud observations values. Means if he want to increase, if he want to make a duplicate of data, he only do the that already present on the data set. Means fraud data set observations he can increase, and he can make the copy, not in making the copy of this true transactions here, observation values. So you are getting proper data set, no? Means if you are increasing the count, if you are increasing the count, that is okay, not an issue, because the last point of your motto, that is an teach to your model, training to your model. So that is the main funda here we have, main thing here we have. So now we discuss about accuracy. See, accuracy purpose, if you want to use, wait, I will pass here one thing. Accuracy we have calculated. No? So where we have, now in period, here we previously used mean of NP function. 78. I previously told you that 78 definitely he will get, right? Not an issue. $76 not an average. 76. 76. Average 78 to 76 that we got. But the point is that now I'm going to think about why not we use one important point. Mm, Confusion matrix actually we have used, but the point is that this is huge work that we have to do here, right? Also, we can get it in difference as well, so that's why. Y test we got it here easily. See where it is here, X and Y test. You can create your custom data set as well. Can you tell me if suppose if I predict print check out now. This is an 154 answers we got. So make a total of this one. Make a total of this one. 74, 28, 18, and 34. So if you calculate this one, sum of these all four values, it will become 154. Is that correct? Is that correct? Check out. Same, no? Same count that we got. Yeah. So actually, how many of the questions you are asked? No, so Y-period and Y-test that you are passing into the confusion matrix, and CM will give them answer, not an issue. Now the point is to be discussed. What is the 74 and 34? So every time you will get in 154, not an issue. But the point to be discussed, check out. 78, 40, 23, 30. Now check out the point of this one. 30 and 30, 23. So 18 and 28. Okay. Yeah. TPTN, FPFN. Yeah. So I will show you the diagram as well. But check out the count. Check out the count. 13, 23, 15, 28, 16, 19. So every time that your accuracy score means your false negative and false positive values are changes. So that is an interesting fact, no? 1523. Every time, check out. So this is an interesting point to be discussed here. If suppose if I'm thinking about 1528, so what are the concept that we have? So let's open this chart of confusion matrix. I think it now it's front of you, right? So true positive, false negative, false positive, and true negative. So this is nothing but your accuracy score. Is it correct? Yes. The true positive and true negative, this is nothing but your accuracy score. So now check out one thing. Hmm. If I am going to print this 90, 28, and 15, 21, you can get it easily to pass these values. Wait, true and true positive and true negative values. Sorry, this one. If you wait, 90 and 21, that is in 111, right? 111. So 111. What is the accuracy score? We got it here. 76. If you make calculation properly, no. So 15 and 28. So what is the 20, 58, 15 and 28? So this is 30, 42, right? So 154 out of 42 are getting wrong answer. So getting wrong answer means it's almost 154 minus 43, maybe 43, no? 30 and 40, yeah, 43. So 43 is become, now check out, 43 means how much remaining? 11. Is it correct? So every time, no, you have to check out this one. So every time, so every case of that, you'll get it that some amount of accurate concept. So if suppose if I'm getting 111, no, so this is, I don't know the which loop it is I'm working on it. Check out the values, 1828. So you can copy this one, no, easy, like this. This is first, this is second, 28% false and 70. Yeah, every time, if you make a calculation of everyone, so 28, 28, 28, 18, 18. Sometimes your accuracy is in changes here. So 23 and 15 as well. So we have to make a calculation of this one. So everything that I have mentioned here, so we have to do this kind of calculation. Okay. So difference into this one as well. So if suppose 154, in that how much difference we got it here easily we can find out. So if suppose uh, 30 and 40, 46, right? How much it is? 46, 36, 36. This is and how much it is? This is correct. 28 and 15. This is also a correct. 23 and 15, 38. So now you can calculate this one. 154 minus 46. How much it is? 4 and 4. 8. 108. Is it correct? So 156, 36 means 14 and 4. 18. 118. Now this is and same, no? Yeah, no, actually 18. Yeah, this is same now. Okay, one is remaining, one is remaining. And if you think about this one, no, this one 38, so become 30, no, okay. So 38 means 12 and 4, 16. Yeah, is all 144. Yeah, 154. So how many values that we have passed here? Check out. No, no, not on 154. Maybe, yeah, I got to your point. 44, wait, 9, 10, 100, and this is 110, 153. This is on 53. Yeah, 53 minus 38. This is 15. Yeah, the last loop. Why this is getting the last loop? How much data is remaining? He is taking that much. But the point is, if suppose if I'm getting this much of concept here, means this much of data, this is in my true transaction and this is my false transactions. It's always depends upon the how we can reduce this means working. If suppose is that we can increase the cross validation means cross validation k fold. The second thing is there is an suppose another one thing that I'm going to discuss increasing and balancing. If suppose if I change the smooth, is that correct? Smooth, smooth. I'll pass here random oversampler. Is that correct? So I'm just using random oversampler. So ROM. So ROM is I'm just passing side by side. You can check it easily. ROM. Random oversampler is not import. Okay. we have to always remember that how much difference that we got it with the smooth with the oversample random oversampler. And if suppose your data isn't big, just imagine what I'm saying. Your data is kind of credit card fraud detection or more than that. So then you can implement the small, what is that? Undersampling technique. Why? Because if you are implementing undersampling, that becomes data is become near about 3 to 4,000. No, that's okay with the huge amount of data set. But if you are using undersampling on small data set, then definitely that is unethical. Means how can you teach your data is a 50 to 100 of data to the model? So how can he understand? How can he believe on your accuracy score as well? Now we have to check. Hmm. Hmm. I think we got the same, right? Is that anything difference that we got? Where we have to check the difference, where we have to check with the difference. The last amount that we have here, this one, where I will come from the beginning of this one. The first, this, so answers also getting same, not an issue. Check out. Yeah, same. And you guys are thinking about this is happens. Yeah, this is happens. It doesn't matter because you are working on the binary classification. No, there is a not a multi classification issues are there. If suppose some word, if you try to change the random state and all, that time it's expect that time we can expect the changes. Sometimes it is same. If suppose I will check the same content as smooth. Okay, something I have missed here. Wait. Smooth and oversampler technique are saying no. Oversampler is an increasing. It doesn't matter that data how we are increasing. Means only he can make the duplications and all, not an issue. Smooth is not making a duplication. If suppose see one thing that you have to remember, the classification count is increased, not an issue. Means dependent variable increased till suppose mean minority is there. See minority is there. He's become a majority till this much. We got it. But side by side, you are increasing the count of X underscore data as well till the 1000. But the way you are increasing X data using oversampler can do duplication of data. But increasing the X data in smooth, he's not making a duplication of data. He's increasing the artificial. He can calculate and increase. Are you getting a point? That is the difference. The artificial, you have to use the word of artificially. He can increase the, but in the oversampler, you cannot use the artificial increase. Somewhat we can get it difference into the output, somewhat. But whenever if you think about the working with the oversampler and undersampler, the stages that you have to maintain, no, that is important. So every time people get confusion into the what we have to do with the cross validation, what we have to do with the imbalancing. So cross validation is completely different. Is it correct? And imbalancing is completely different. Implementation is important, both of the things. All right. And say one thing, the way we have checked here, this observational values, this observation values that is an with uh, random over sampler, with the random over sampler. See, and this is become smooth. Output we are working on. Okay, this is an output. Is that correct? With the random oversample model prediction with the same observations, with the same observations, right? But the way I'm getting the answer, it's not meaning that you also will get the answer. No, actually, if you are trying with the different way, then you will get a different. Why? Because random state matters. Test size means this is shuffling is matters, right? So when we work on the content, no. See, one thing I would like to tell you. Hmm. What are the factors? Algorithm. Which algorithm you are using? Okay. And the last one you are using. See, see. Now the major thing about this outcome of this whole process, that is, you know, the trust of your model means the previous time we have applied on the only single data set. Okay, here you are getting a multiple accuracy scores, multiple confusion matrices, multiple data sets as well, because your test size changes every time while while execution of program, right? And you are applying different subsets on a single algorithm. Is it correct? So if suppose if we are not doing the cross validation technique, then definitely in the previous time only single data set you have to apply on the algorithm and get it output. And suppose if you want to do this process in a basically means previous time that we have done a train test split, then definitely you will get a time, and there is an time also means increased to implementation of this one. So now the test size changes, training size is changes, test data changes, training data is changes. Even while working on the imbalancing problem, even he is going through the balancing content as well. So I would like to tell you one thing here. If you are working on the cross validation, the scaffold and stratify, no, always try to make a count of data, a count of data means extract and train extrain and extract data. Okay, so count is important. How much the data he is taking means, the x-test count is also important, no? X-test and y-test data. So what is the, see, one thing I would like to tell you one. Wait. See it now. So the way we got an imbalancing problem, if suppose check a zeros count and ones counting y-test, you are passing a y-test to what is the total count of this one? 4 and 154. Let me know, is it correct? You are passing 154 values, y-test to the model, no? Is it correct? So every time when loop is executing, no, this this data should balance. Means every time he should give the balancing data to the model for training purpose. Is it correct? So now check out the count. 91 zeros and 63 ones are there. See now, 105 and 49. See, every loop we are getting imbalancing. Every loop in y-test only because you are teaching to the model. Check out this one, 10350, 10945. So every loop we are getting imbalancing. If I'm using mm, stratify, check out now, check out. For the stratify purpose, you have to pass y because he is going to balance with the y as well. Check out now. 154 now. Check out 154, 154, 153, 153. Are you getting now point? What is the difference between stratify cross validation technique and K-fold cross-validation technique. Is that correct? He is giving you a stable amount of values to the teaching purpose, to the training purpose, to the model. So every loop. Are you getting everyone what I'm telling to you? The K-fold is not going to balance, not going to give this means stable amount to the model. But stratify, he always gives you a stable amount of value. So 153, 154, some amount that matches to the Y test. Is that correct? Yes or no? So now, one thing that you have to do, see, if suppose if I'm applying a stratify cross validation technique, what is the impact we got into the prediction that we have to check? Is that correct? If I'm applying stratify, what you have to take observation values kind of this one, this one. If suppose if you want to work with the cross validation, you have to use a random oversampling with stratify, smooth with stratify, then random oversampling with the k-fold, and smooth with the k-fold, and you will get an four major models of observation values, means prediction values. Is it correct or not? So is it possible from your side that you can do this work? Tell me yes or no. So now I think you got the whole process of implementing, start to end process of this implementation. You know, this is important. Why? Because so many people are thinking about where this algorithm ends. So this is the position that your algorithm ends here. Means your whole process, start to end process is ending here. Cross validation technique till cross validation technique. Okay. So see, still we haven't gone through the decision tree and all, but these are the problem solution techniques. No, what is the algorithms? Algorithms are nothing but problem solution techniques. Okay, you are passing only data to them and getting the output. So that is not a big deal. But big question is that where your project is starting and where is an ending. So once you got this one, you have to change only the problem solution techniques in between that. If you change decision tree to SVM to the random forest to the logistic regression, it depends upon you what type of answers you are getting. So every time it's not necessary to go for 6 to 7 algorithms that you can implement easily. It depends upon the how much experience you have to implement any one single algorithm and means maturity level. R&D sections are important. Okay, so see, I think last 2 to 3 weeks we have implemented so many work with the cross validation, in balancing technique, because these are the critical things to understand. So maybe go for the repeat and repeat topics of these sessions so that you can get it easily. Yes, so we have to check with the k-fold stratify, with the k-fold stratify, k-fold random or sampler and smooth. Yes, every time, every time. See, it depends upon you as well, because if suppose if you think about your data is in balance, if you check my data is enough for to train this much, then you can. But ethically, if you think about, then these are the things are important. Means cross validation techniques and imbalancing techniques to understand, and means making balanced purpose. Yeah. So hope so. Today's topics you got, and today you got the whole process. Okay. So when we come tomorrow, no, tomorrow we are going to work on the decision tree as well. Okay, decision tree and other library, other algorithms as well. So till then, do the exercise, and we are going to come up tomorrow. See you. Take care.